In this lesson, we'll be discussing simplifying algebraic expressions. A variable is a symbol used to represent a number. A combination of operations on variables and numbers is called an algebraic expression or simply an expression. The following are examples of algebraic expressions. 4x to the third, negative 7n plus 9, 8a plus bc minus 2. A term is a number or a product of a number and variable raised to some power. Terms are separated by addition or subtraction. Let's identify the terms in each of the following algebraic expressions. 4x to the third. Since there is not an addition or subtraction symbol, there is only one term. In the next example, we do see an addition sign. That tells us we have more than one term. In fact, we have two terms, negative 7n and positive 9. In the third example, we have both an addition and a subtraction symbol. This gives us three terms. A term that is only a number is called a constant term or simply a constant. A term that contains a variable is called a variable term. The number factor of a variable term is called the numerical coefficient. Let's identify the numerical coefficients of each of the following terms. 4x to the third. We've already identified that this is a single term. It is a variable term, since we see a variable. Therefore, we should have one coefficient. That one coefficient is 4. In the next example, we see a fraction, but no addition or subtraction symbols. There's one term here, therefore there should be one numerical coefficient. We can rewrite the numerator as 2 times y to the 6th and the denominator as 3 times 1. Using the rule for multiplying fractions backwards, we can split this up into two separate fractions. 2/3 times 6y to the 6th over 1. Y to the 6th over 1 can be simplified to just y to the 6th, which gives us 2/3 times y to the 6th. The coefficient is the number factor, and the number we're multiplying by is 2/3. In our next example, we've already seen that this is two terms. Each term that is a variable term will have a coefficient. Positive 9 is not a variable term. Therefore, this term will not have a coefficient to it. Only negative 7n will have a coefficient. The number we're multiplying by is negative 7. That's our coefficient. In our fourth example, we see that we have three terms. The last term, however, is not a variable term, so it does not have a coefficient. The coefficient for our first term is 8. In the next term, we don't explicitly see a number in front. When there isn't a number written in front, there's like an invisible 1 there. The coefficient of that term is positive 1. Terms with the exact same variables raised to the exact same corresponding powers are called like terms. Please note that the variables do not have to be in the same order. Let's determine whether or not each set of terms are like. 2x and 3x. We ask ourselves, do we have the exact same variables raised to the exact same power? The first term, x to the first. The second term has x to the first, So yes, indeed, these are like terms. In our next example, 4a squared b to the third c to the fourth and 11b to the third c to the fourth a to the second, we want to see, do we have like terms? In the first term, I have a to the second. Do we have that same variable raised to the same power in the second term? A to the second, yes. Then we look and we see b to the third. Do we have b to the third in the second term? Yes, we do. Lastly, c to the fourth in the first one, c to the fourth in the second one. These are like terms. It's most common that we will have different numerical coefficients on our terms, whether they're like or not. Our last example, 6mn squared and 8nm squared. I'll go through the same way. The first term has m raised to the first power. Does the second term have m raised to the first power? No, it doesn't. It has m raised to the second power. So these are not like terms. Like terms can be combined by applying the distributive property. Recall the distributive property of multiplication over division. A times the quantity b plus c is equal to a times b plus a times c. It is possible that the multiplier is at the back, and we just distribute it in the same way as we did the first. Consider 2x plus 6x. Using the distributive property of multiplication backwards, this can be rewritten as 2 plus 6 times x. Following our order of operations, we'll add what's in the parentheses first, which gives me 8, and then the x is still there. So 2x plus 6x gives us 8x. An algebraic expression is simplified when all like terms have been combined. Let's simplify each expression by combining like terms. The first thing you want to do is identify whether or not you have like terms. 8m minus 14m. Those are like terms. Each have the variable m raised to the first power. So now all we need to do is add or subtract the coefficients. 8 minus 14 gives us negative 6m. In our next example, we see that not all terms are like. We have variable terms that are like, and then we have constant terms that are like. Let's combine the variable terms first. 6z plus 1z gives me 7z, and positive 5 minus 4 is a positive 1. This algebraic expression simplifies to 7z plus 1. Let's practice using the distributive property. We're going to multiply 3 times 7a. And since this is a positive 3, when I rewrite, I'm going to write plus 3 times negative 5. Now we multiply. 3 times 7a is 21a. A positive 3 times a negative 5 minus 15. In the next example, we're distributing a negative number, so be careful with your signs. Negative 6 times 5, and then since we're distributing a negative 6, I'm going to write minus 6 here times a negative y. Negative 6 times 5 is negative 30, and a negative 6 times a negative y gives me a positive 6y. Next, we're going to simplify expressions by first applying the distributive property and then combining any like terms that we might have after we've distributed. I start by distributing my 5. 5 times 2y plus 5 times a negative 3, and then I'm just going to bring that minus 8 down. 5 times 2y gives me 10y. A positive 5 times a negative 3 minus 15, and then we bring down that minus 8. Now we want to look and see, do we have any like terms that we could combine? Yes, we do. We have constant terms that can be combined. Bring down the 10y. Negative 15 minus 8 more gives me minus 23. In our next example, we start by distributing the 3 only to the first parenthesis. So that's 3 times 2x, and then a positive 3 times a positive 1. This next part can sometimes be tricky because we don't see a number in front of the second parenthesis. Now, when a number isn't shown, there is an invisible 1 there. So we're going to be distributing a negative 1. It would be negative 1 times 5x, and then a negative 1 times a negative 1. Now we can multiply these 4 groupings. 3 times 2x, 6x. A positive 3 times 1 is 3. Negative 1 times 5x minus 5x. And negative 1 times negative 1 gives me a positive 1. At this point, we want to look to see if we have any like terms and then combine those like terms. We actually have 2 sets of like terms. We have these variable terms containing x's, and then we have constant terms as well that can be combined. 6x minus 5x leaves me with 1x. You can either write the 1 in front of the x or not. A positive 3 plus 1, positive 4. So we can either write our answer as 1x plus 4 or simply x plus 4. It's understood that there's a positive 1 when we don't have a number in front of our variable. Next, we're going to translate words into symbols. I've listed a whole bunch of different words here that mean addition, subtraction, multiplication, division, or equality. A couple that I would like to point out to you are less than and subtracted from. You'll notice I've marked them with an asterisk. I call these switcher words, and the reason for that is when we go from the sentence to the algebraic expression that we're going to write, we actually switch the order. We'll see that show up later on in our examples. Let's start with 4 times a number added to 15. 4, we know, is the number 4. The word times means multiplication. A number, well, that's our unknown. We'll replace it with a variable. I'm going to choose x this time. Added to means addition. And then with the number 15. So I'm just going to write this a little bit nicer. We would rewrite this as 4x plus 15. We want to check to see, do we have like terms that we can combine? We do not, so this is our answer. The difference of a number in 3 divided by -2. I see the word difference. That tells me subtraction. It is not a switcher word, so I'm not going to switch the order. a number, well, that's my variable, and 3. So I need to subtract a number, which is unknown, and the number 3. So we write that x minus 3. Now we want to divide all of that by negative 2. How do I know I'm dividing all of that by negative 2? The comma. To write the division, we want to use a fraction. So all of this is going to be divided by the negative 2. We look for like terms. We don't have any. This is our answer. Nine added to twice the sum of negative 5 and a number. We have the number 9. Added to means addition. Now we have twice the sum of negative 5 and a number. We know that twice means 2 times, but what we need to multiply by 2 is a sum. We need to indicate that the addition, the sum, has to happen first. The way that we're going to indicate to do something first, like we have many times in math, is by using parentheses. So inside the parentheses, we want the addition of negative 5 and some number, let's call it x. I'm going to write this a little bit nicer and then see if it can be simplified. I'm going to rewrite this 9 plus 2 parentheses negative 5 plus x. I see that distribution can happen here, so I'm going to distribute the 2. A positive 2 times a negative 5, and then a positive 2 times a positive x. Multiplying those, that gives us 9 minus 10 plus 2x. We want to check for like terms. I see that we do have like terms, like constant terms. 9 minus 10 is negative 1 plus 2x. That is our simplified answer. Our last example, subtract 7x minus 1 from 4x plus 6. I see that subtract from. We've been waiting for it. This is a switcher, which means that whatever comes after subtract from should come first in our algebraic expression. So 4x plus 6 actually goes first. Now I want to subtract that whole thing, 7x minus 1, from the 4x plus 6. To indicate that we're subtracting the whole thing, I need to put 7x minus 1 in parentheses. To eliminate the parentheses, we distribute. As we discussed before, when there's not a number in front, there's an invisible 1, which is what we'll be distributing. 4x plus 6 comes straight down, and now we distribute. Negative 1 times 7x, and a negative 1 times a negative 1. We multiply. 4x plus 6 minus 7x plus 1. The last thing we need to do is look for like terms and combine any if we have them. Notice that we have like variable terms and we have like constant terms. Combining our variable terms, 4x minus 7x is negative 3x, and a positive 6 plus 1 is positive 7. This simplifies to be negative 3x plus 7.